All right, so welcome everyone. In this video, we'll be focusing on median in statistics, or how to calculate for median in statistics. Now, first of all, let's look at median. What is median? When we say median, we are looking at the middle value when a data set is arranged in either ascending or descending order. Now, usually a lot of people think median is the middle number. If we give you a data set and it's not arranged in order, median may not be the middle number. So typically in statistics, median is the middle value when a data set is arranged in either ascending or descending order. Now let's look at a typical example of a data set. We will start calculating or looking at median when you are given a raw or a simple data. So our first data, all right, so we have this data set. Now, when we give you a data set like this, before you calculate for the median, okay, the principle is that you first have to order the data set. Okay, when you get a data set like this, before you calculate for the median, make sure the data is arranged in order. Usually arrange the data in ascending order. So let's order the data together. So you order the data. Now, our minimum value here is 2. We have another 2. We have 3. We have 4. We have 5. We even have 1 over here. And then we have 8. So we have 1, 2, 3, 4, 5, 6, 7. Let's confirm 1, 2, 3, 4, 5, 6, 7, 8. Meaning we've missed a number. Which one did we miss? There should be another 8. Okay, good. So, and usually when we give you the raw data, count again to confirm. So we have 1, 2, 3, 4, 5, 6, 7, 8. In the ordered data, we have 1, 2, 3, 4, 5, 6, 7, 8. So you have to recount again to confirm. Now the number of observations. So 1, 2, 3, 4, 5, 6, 7, 8. Meaning in the raw data and then the ordered data, n is equal to what? 8. And this is an even data. Okay. So anytime we give you the data set, first of all, check whether the data is ordered. Okay. In this data, you can see clearly the data is what? It's not ordered. So you order the data. Then now count the observations. So 1, 2, 3, 4, 5, 6, 7, 8. The observations are 8. Okay. Now, the simple approach to use. Let's use the simple approach. In the simple approach, when we give you an even data, this is an even data. When we give you an even data, the principle is that in an even data set, you are going to have 2 numbers in the middle. Okay, so this is an even data set. Why is it an even data set? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 observations, and 8 is even. So it's an even data. In an even data, there is going to be 2 numbers in the middle. Okay, so you take one out here, you take another one out here, you take one out here, another one out here, one out here, another one out here. We have 2 numbers in the middle. Now, the principle here is that the median is equal to the average of those 2 middle numbers. So 3 plus 4 divided by 2. And that will give us 7 divided by 2. That will give us what? Come again? 3.5. Okay, so this is an even data. Okay, so in an even data, the median is the average of the 2 middle numbers. Anytime you are given an even data, 2 numbers will fall in the middle. Now let's look at an odd data. Let's look at an odd data. Now in an odd data, we have, let's do 5, 2, 3, 4, 8, 10, 5, 7. All right, so we have this data set. This is an odd data set. When we give you a data set like this, it's an odd data. Okay, so how do you know it's an odd data? You count the number of observations. 1, 2, 3, 4, 5, 6, 7. The observations are 7, meaning n is equal to 7. Once the observations are 7, it's an odd data. Now, the next principle in calculating median is that you have to order the data. Make sure the data is ordered. So you order data. Now, in ordering the data, let's observe which one is the minimum. The minimum is 2. Which one is the maximum? The maximum is 10. So we have 2. We would have 2. We would have 3. We are going to have 4. We are going to have 5. We are going to have 7, 8, and then 10. Now, afterwards, let's recount the data again to confirm. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Is that okay? It's always very important. After ordering the data, you recount the data again to confirm, because sometimes you can leave some of the observations out. Okay, so now it's intact. We have 7 over here, we have 7 over here. Now, the principle is that if the data is an odd data, the median is going to be a single middle number. Okay, so let's use the simple approach. We have 1 here, 1 here, another 1 here, another 1 here, 1 here, 1 here. So we have 5 falling in the middle. So the median to this data set is 5. Okay, so the principles are simple. When we give you an odd data set, the median is going to be a single middle number. When we give you an even data set, the median is going to fall on 2 numbers. You find the average of those 2 numbers to get the median. Okay, great. Let's look at 2 more examples of a raw data set. Let's look at 2 more examples. Example 3. Now, this is our data set. So we have 4, 5, 2, 1, 1, 3, 8, and 15. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is an even data. Okay, so let's do our analysis and calculate for the median. Okay, so now this is an even data. You can write even data. Now, for an even data, how do we know it's an even data? Count the number of observations. 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. So the number of observations are 8. And that tells you that when you order the data, the median is going to fall on 2 numbers. You find the average of those 2 numbers to get the median. Let's order the data. Order data. Now, when you order the data, check the minimum value. It's 1 over here. The maximum is 15. So we have 1, 1, we have 2, we have 3, we have 4, we have 5, we have 8, and we have 15. Now, after ordering the data, recount the data again. Because sometimes when during the ordering of the data, it's possible you can omit some of the observations out. So 1, 2, 3, 4, 5, 6, 7, 8. Confirmed. Is that okay? Yes. Now, the principle is that the median is going to fall on 2 middle numbers. So let's take 1 here, 1 here, 1 here, 1 here, 1 here, 1 here. So we have 2 numbers falling in the middle. Okay, so the median is equal to 3 plus 4 divided by 2. And this will give us 7 divided by 2. This will give us 3.5. This is the median. Is that okay? Now let's look at our 4th example of a raw or simple data. All right, so we have a data set. We have 15, we have 12, we have 9, we have 8, we have 4, we have 5, we have 2, we have 2. Let me add 3 to the data set. Now, this is an odd data set. So when we give you a data set like this, ask yourself, is it an ordered data? Okay, so this is not an ordered data. In calculating for median, one principle holds. Irrespective of the method you are going to use, you have to get the data ordered. It's a principle in median calculation. So let's order the data. Now, in ordering data, check the maximum value is 15 over here. The minimum is 2. So we have 2, we have 2, we have 3, we have 4, we have 5, we have 8, we have 9, we have 12, and then we have 15. After ordering the data, recount the observations again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It means that we are on track. Okay, because the observations are the same in both the original data and the ordered data. Now, if the data is odd, the principle is that the median will be a single middle number. If the data is an odd data, the principle is that the median will be what? A single middle number. Now let's check. So we have 1 over here, 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 1 over here. The median falls on 5. Okay, so the median for this data set is equal to 5. Is that okay? So this is how to calculate for median in a simple data set. And this is the simple approach. Okay, now let's look at how you calculate for median using a formula we call the position formula. All right, so we are going to look at how to calculate for the median using a formula we call the position formula. Okay, now the position formula comes in 2 forms. We have a position formula when you are given an even data set, and we have the position formula when you are given an odd data set. Let's start with the odd data set. Now with the odd data set, let's look at a typical example of an odd data. So we have 2, we have 5, we have 5, we have 8, we have 9, we have 10, we have 11. 1, 2, 3, 4, 5, 6, 7. This is an odd data set. This is an odd data set. Now, the position formula for median, when you are given an odd data set, the formula says that median position is equal to n plus 1 all over 2 position. So the position formula for an odd data set, when you are given a data set to calculate for the median using the position formula, this is the formula you are supposed to use. Now remember, this formula will not give you the median. This formula will give you the median position in the ordered data. Okay, so the principle still holds when you are using this formula. So first of all, get the data ordered. Okay, get the data ordered. Let's order the data together. Now, in ordering the data, check the minimum. So the minimum here is 2. So we have 2, we have 5, we have another 5, we have 8, we have 9, we have 10, and we have 11. In fact, this data is already ordered. Okay, now state the number of observations or count the number of observations. 1, 2, 3, 4, 5, 6, 7. So n is equal to 7. Then now you can state the position formula. The formula states that if the data is an odd data, the median position on the ordered data is n plus 1 all over 2 position. So now let's interpolate all that into the formula. So our n is 7. Is 7. The number of observations. How did we get a 7? 1, 2, 3, 4, 5, 6, 7. So the n is 7. It represents the number of observations. So let's put that into the formula. So we are going to have 7 plus 1 all over 2 position. Okay, so we are going to get 8 over 2, and that will give us 4th position. Now remember, when you get this answer is not the median. This answer represents the position. So what it means is that go to the ordered data, count the value on the 4th position. So you come, when you get this answer, it represents the position. So come to the ordered data, not the unstructured or unorganized data. Come to the organized data, the ordered one, and check the value on the 4th position. That's the median. So let's do that together. 1, 2, 3, 4. So this number on the 4th position is 8. So therefore, the median is equal to what? 8. Is that okay? If you doubt, you can still use the simple approach to confirm. So in using the simple approach, you take one out here, take one out here, take one out here, take one out, take one out here, take one out here. The median will still fall on 8. Remember, what confuses students when they are using the position formula is that there are times they settle on the answer for the position as the median. Okay, so this one just shows you the position. So you go to the ordered data and then you count the number that falls on that position. Okay, now let's look at another example. Let's look at another example. 4, 8, 8, 2, 5, 7, 1, 3. 1, 2, 3, 4, 5, 6, 7, 8. Let me add 2. Okay, so this is a data set. Okay, now when we give you a data set like this, you want to use the position formula. First of all, count the number of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9. The observations are 9, meaning n is equal to 9. Okay, and this tells you this is an odd data set. Is that okay? Good. Now, state the position formula. What is the position formula? The position formula for an odd data set is n plus 1 all over 2. Okay? Good. Now, what is our n? 9. 9 plus 1 all over 2. That will give us 10 over 2. That will give us feet position. Remember that this feet is not the median. It's the median position. Okay? Good. Now, get the data set ordered. So we will order the data. In ordering data, check the minimum. The minimum here is 1. The maximum here is 8. So 1, 2, 2, 3, 4, 5, 7, 8, 8. And you finish ordering it, recount again to confirm. 1, 2, 3, 4, 5, 6, 7, 8, 9. Confirmed. Okay. Then now, this position tells you that come to the ordered data, count and get to the value on the feet position. That is the median. So 1, 2, 3, 4, 5. So this value here, 4, which is on the feet position in the data set, that is the median. So median is equal to 4. Remember, when you get this 5, it represents the position. The answer you get from the median position does not represent the median. It represents the position of the median in the data set when it is ordered. It represents the position of the median in the data set when it is ordered. And again, in statistics, we can ask you also, the reason why knowing the median position is important is we can ask you to calculate for the position of the median. But another trick is that you can even identify that even with a simple formula. Because see, if you order the data, in all the approaches, you have to order the data. When you order the data, and let's assume you used the simple approach, you are going to do one here, one goes 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 down here, one goes down here, one goes down here. At the end of the day, the median is 4. If the question is asking you the position of the median, you can still count 1, 2, 3, 4, 5. And know that the position of the median is feet. So someone who used the position formula would also get feet position when they use the position formula. Because in an exam, we can ask you that this is a data set. What is the position of the median? So here, we are not asking you to calculate for the median. We are asking you to calculate for the position of the median. Is that okay? Yeah, so for a data like this, if we ask you to calculate for the position of the median, the answer will not be 4. The answer is 5. But you have to know the median first before you count 1, 2, 3, 4, 5. Is that okay? Is that okay? Yeah, so this is how we calculate for median using the position formula when you are given an odd data. Now let's look at the position formula when you are given an even data. Let's look at the position formula when you are given an even data. Right, so for an even data set, let's look at a typical example. So we have 4, we have 3, we have 2, we have 10, we have 7, we have 9, we have 2. 1, 2, 3, 4, 5, 6, 7. Let me add 2 over here. So this is a typical example of an even data set. Now, when we give you a data set like this, if you are going to use the position formula, first of all, count the number of observations. How many observations are here? 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. So the number of observations here are 8, and that tells you that it is an even data. Now, the position formula for an even data states that the position formula or the median position for an even data states that the median is the n over 2 and n over 2 plus 1 positions. So if you are given an even data, the formula says that the median is the average of the value on n over 2 position and n over 2 plus 1 position. Let me take it again. Now, if you are given an even data, the formula or the position formula for calculating for median states that the median is the value, the average of the values on the position n over 2 and n over 2 plus 1. Remember, this is not median, this is positions. What you get from these computations represent positions. Okay, so the formula is just saying that if the data set is an even data, the median is the average of the values on these positions, the average of the values in the data set that falls on these positions, the average of the values of the data set that falls on these positions. But remember, the principle is that with median, you always have to order the data first. Now, let's get the data ordered. Check the maximum number, which is 10 over here. The minimum is 2. So we have 2. We have another 2 over there. We have 1, 2. We have another 2. We have 3. We have 4. We have 7. We have 9. We have 10. Recount again. After ordering the data, recount again to be sure that the data is up to 1, 2, 3, 4, 5, 6, 7, 8, meaning we still have the 8 over here, so it's confirmed. Now, let's apply the position formula. So the formula says that if you are given an even data, the median is the average of the values that falls on the position n over 2 and n over 2 plus 1 positions. So let's do the computation. So n over 2, let's calculate this position first. The n is 8, so 8 over 2. That will give us 4. So fourth position. Let's do the second position. 8 over 2 plus 1. That will give us 4 plus 1. That will give us fifth position. So it means that the median is the average of the value on the fourth position and the value on the fifth position when the data set is arranged in order. Remember, this does not represent the median. This does not also represent the median. The mistake a lot of students make over here is that they will add this 4 to this 5 and divide by 2. That is wrong. Okay, so it's telling you that go to the ordered data set. Remember, go to where? The ordered data set. And locate the value on the fourth position. So 1, 2, 3, 4. And that is 3. And locate the value on the fifth position. 1, 2, 3, 4, 5, which is 4. The principle states that add these two values and divide by 2. So 3 plus 4 divided by 2. That will give us 7 divided by 2. That will give us 3.5. So the median is 3.5. Okay, so when you are given an even data set, this is a simple data or a raw data. When you are given an even data set, the principle states that, okay, the median is the average of the values on the positions n over 2 position and n over 2 plus 1 position. Okay, so you do that substitution. The n is 8. How did we get the 8? 1, 2, 3, 4, 5, 6, 7, 8. The observations are 8. That is the n. Okay, so you do the computation. So you calculate for this position, and that gave us the fourth position. You calculate for this position, that gave us the fifth position. Is that okay? Then you order the data. Now, when you order the data, the principle says that look for the value on the fourth position, and that is 1, 2, 3, 4. That is 3. That is what we have over here. Look for the value on the fifth position. 1, 2, 3, 4, 5. That is 4. Okay, now find the average of the values on the fourth position and the fifth position. So the average of 3 and 4, and that is 3 plus 4 divided by 2. That gave us 3.5. So the median is equal to 3.5. Is that okay? All right. We can do another last example for the even data using the position formula. So let's look at 2, 8, 4, 5, 7, 7, 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is a typical example of an even data. 4, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a typical example of an even data set. Now, what is the principle? When we ask you to calculate for median, remember, irrespective of the formula you want to use, you always have to get the data ordered. Let's order the data first. Now, check the minimum number. It's 1. So we have 1, we have 2, we have 4, we have another 4, we have 5, we have 7, we have another 7, we have 6, we even have 6, we have 7, we have 7, we have 8, and we have 8. Now, after ordering the data, recount again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the observations are 10. So n is equal to 10. Now the position formula for median, when you are given an even data set, states that the median is n over 2 position and n plus 1, n over 2 plus 1 position. Be careful not to write it n plus 1 over 2 position. You may end up getting a wrong answer. So it's n over 2 plus 1 position. So what it means is that when you are given an even data, you want to use the position formula. The principle is saying that the median is the average of the values on n plus 1 position and n over 2 plus 1 position. So what it means is that on the ordered data, the value on this position and the value on this position, find their average. That is the median. Let's calculate this position first. Now, n is 10. So 10 over 2. And that will give us 5. Remember, this one represents position. Now, let's do for this. N over 2 plus 1. That will give us 10 over 2 plus 1. That will give us 5 plus 1. That will give us seat position. Seat position. So what it means is that go back to the ordered data. Go back to the ordered data. Look for the value on the feet position and look for the value on the seat position. The median is the average of those two values. So let's count for the feet position. 1, 2, 3, 4, 5. Let's count for the seat position. 1, 2, 3, 4, 5, 6. The principle says that the median is the average of the values on this feet position and this seat position. So it just means that you add 5 plus 6 and divide by 2. And that will give us what? 11 over 2. That will give us 5.5. So this is the median. Okay? So all that we've been doing here, we've been looking at a simple data set. Okay, so these are the procedures that you can go through to calculate for median in a simple data set. Now, let's go and look at how to calculate for the median when you are given a frequency distribution table. Now, when you are given a frequency distribution table, the principle for calculating median is different. Now, the concept of what we call cumulative frequency comes in. Okay, so when you are asked to calculate for the median on a frequency distribution table, the concept of what we call cumulative frequency comes in. Now, what is cumulative frequency? Cumulative frequency simply means addition of frequencies. Okay, adding frequencies. Is that okay? When we say cumulative frequency, it simply means adding frequencies or addition of frequencies. Okay? Now, this concept of cumulative frequency is very important when you are calculating for median in a frequency distribution table, either an ungrouped frequency table or a grouped frequency table. Now, what is cumulative frequency? It has a formula. The formula for cumulative frequency, CF, usually represented by the symbol CF. Okay, now the formula states that F1 plus F2 plus F3 through to Fn. Okay, let's look at what cumulative frequency means practically. Let's look at what cumulative frequency means practically. So for example, let's look at this data set. Let's look at this frequency table. So we have H in years, we have frequency, we have CF, which is the cumulative frequency. Let's say we have 2 over here, we have 5 over here, we have 8 over here, we have 9 over here. Let's make here total. All right, now let's put in some frequencies. So let's make here 4, let's make here 5, let's make here 3, let's make here 2, let's make here 1. Okay, now on this data, let's do the computation. So we have 4 plus 3 will give us 7 plus 2 will give us 9 plus 1 will give us 10. So the total frequency is equal to 10. Now, what is cumulative frequency? It simply means adding frequencies, addition of frequencies. Okay, there are several ways you can compute cumulative frequency. The simplest one is called the vertical approach. The simplest one, we call it the vertical approach. What does it mean? So now we have a principle, but on the cumulative frequency table, we have a principle. The first principle is that the first frequency is equal to the first cumulative frequency. The first frequency is equal to the first cumulative frequency. The first frequency is equal to the first cumulative frequency. So meaning if the first frequency here is 4, the first cumulative frequency too will be 4. Now the second principle is that the last cumulative frequency is equal to the total frequency. The last cumulative frequency, which is 10, is equal to total frequency. Now, the third principle is that we do not have total cumulative frequency. Okay, so we do not have total cumulative frequency. Okay, let me go over the principle again. Now, the principle states that the first cumulative frequency is equal to the first frequency. So if here happens to be 2, here will be 2. If here happens to be 4, here will be 4. If here happens to be 5, here will be 5. The first frequency is equal to the first cumulative frequency. Here is 4. That is why we have 4 over here. The second principle is that the last cumulative frequency is equal to the total frequency. Last CF is equal to total frequency. So the last cumulative frequency is equal to total frequency. The last principle is that we do not have total cumulative frequency. Because you see, if you want to do total cumulative frequency here, you may end up writing 10 again over here. And that is not done in statistics. So here we usually put dash over here, or you don't write anything there at all. Okay, great. And all right, so let's continue. So we are going to use the vertical approach to get the rest of the frequencies. Now, the vertical approach means that if you want to get the cumulative frequency here, just add the frequencies till you get to this point. So it means you add this 4 to this 3, you get 7 over here. If you want to get the cumulative frequency here, add the frequencies till you get to this point. So you add 4 plus 3 plus 2, then you get 9. If you still don't believe that the last cumulative frequency is equal to the total frequency, you can go ahead to add to confirm. You add 4 plus 3 plus 2 plus 1. You will get the 10 over here. But all the time, use the principle. The principle states that the last cumulative frequency is equal to the total frequency. The last cumulative frequency is equal to the total frequency. All right. So let's go over it again. So the vertical approach means that if you want to get the cumulative frequency for 4, frequency 4, The first frequency here is the same as the first cumulative frequency. If you want to get the cumulative frequency for frequency 3, add the frequency from the top till you get to the 3. So 4 plus 3, that will give you 7. If you want to get the cumulative frequency for the 2 here, the cumulative frequency here, add the frequency from the top till you get to the 2. So 4 plus 3 plus 2, that will give you this. Now, the next principle states that if you want to get the cumulative frequency for this, add the frequencies till you get to this point. So you add 4 plus 3 plus 2 plus 1. That will give you 10. But remember, all the time, apply the principles. The last cumulative frequency is equal to the total frequency. The last cumulative frequency is equal to the total frequency. Now, this is the vertical approach. This is the vertical approach. This is the vertical approach. Let's look at the diagonal approach. Let's look at this, the vertical approach. Let's look at the diagonal approach. Now, with the diagonal approach, you add the previous cumulative frequency to the next frequencies. So you go this way. You add the previous cumulative frequencies to the current frequencies. So this is the previous cumulative frequency. If you want to get the cumulative frequency here, add the previous cumulative frequency to the current frequency that you are looking for its cumulative frequency. So if you want the cumulative frequency here, add this 4 to this 3. Then you get 7. If you want the cumulative frequency for these 2, here, if you want this 9, add this 7 to this 2. You get the 9. If you want the cumulative frequency here, for this 10, add this 9 to this 1. Then you get the cumulative frequency here. So you add the 9 to 1, you get 10. Okay, this is called the diagonal approach. So we have 2 approaches that you can use to calculate for the cumulative frequency, the vertical approach and then the diagonal approach. So you have to check the one that works for you, then you use it. Let's look at another example. So let's look at another example. So let's look at another frequency table. So let's do the same variable, h. So this time 5, this 10, 12, 15, 20, 22. All right, so when we get a data like this, let's do the total. Let's do the totals first. So we have 6, we have 12, we have 17, 18, 19, 20. But you can confirm if I'm right. So we have 6, we have 12, we have 17, 18, 19, 20. Okay, so now let's do the cumulative frequency. So the principle states that the first cumulative frequency is equal to the first frequency. So if here is 2, here should also be 2. If here happens to be 3, here would also be 3. The first cumulative frequency is equal to what? The first frequency. Now the last cumulative frequency is equal to what? The total frequency. So if the total frequency is 20, the last cumulative frequency would also be what? 20. So these 2 principles are very important. The first frequency is equal to the first cumulative frequency. The last cumulative frequency is equal to what? The total frequency. We do not have total cumulative frequency. So here is dash. We do not have total cumulative frequency. Now let's use the vertical approach to calculate for the frequencies. Now we want the cumulative frequency here. We want the cumulative frequency here. Vertically add the frequencies from the top till you get to the 1. So 2 plus 1, that will give us 3. If you want the cumulative frequency for this 5, add the frequencies till you get to the 5. So you add the frequencies till you get to this point. So 2 plus 1 plus 5. That will give us 8. If you want the cumulative frequency for the 6, vertically add till you get to the 6. So 2 plus 1 will give us 3, plus this will give us 8, plus this will give us 14. Now, if you want the cumulative frequency for these 2, add the frequencies from the top till you get to the 2. So 2 plus 1 plus 5 plus 6 plus 2. That will give us 16. Now, if you still doubt the principle and you want the cumulative frequency here, add the frequency from the top till you get to the 4. You still get the 20 over here. But always use the principle. This is what we call the vertical approach for calculating cumulative frequency. You can also use the diagonal approach. With the diagonal approach, you add the previous cumulative frequencies to the current frequencies. So if you want the cumulative frequency here, add the previous cumulative frequency to this current frequency. If you want the cumulative frequency here, this 8, add the previous one, which is the 3, to the current frequency. It give you 8. If you want the cumulative frequency for this 6, add the previous cumulative frequency to the current frequency, which is the 6, to give you the 14. If you want the cumulative frequency for these 2, which is this 16, add this 14, the previous one, to this. That will give you 16. If you still doubt the principle again, you can still add this 16 to this 4, you get a 20. Okay, this approach is called the diagonal approach. So we have the vertical approach, and then we have the diagonal. We have the diagonal approach. Now let's look at types of cumulative frequency. Now the usual type of cumulative frequency that we've been calculating, okay, we call it the less than cumulative frequency. So we have 2 main types of cumulative frequency. So we have 2 main types of cumulative frequency. The first one, we call it the less than cumulative frequency. Or the less than CF. And then we have the second one, we have the more than cumulative CF. So we have the less than cumulative frequency and then the more than cumulative frequency. The commonest one is called the less than cumulative frequency, or this is the commonly used one. This is the usual one that we usually do, the less than cumulative frequency. Let's look at how it works. So for example, let's look at this data. For example, let's do 5, 7, 8, 8, 2, 10, and then 12 and 12. This is a typical, let me add 10, 10, and 12. Yes, let's look at this data. Okay, now let's draw a frequency table or a cumulative frequency table for this data. Okay, so we would have our values over here, which is the x. We would have our frequency over here. We would have our cumulative frequency over here. So the numbers, we have 5. The values, we have 5. We have 7. We have 8. We even have 2. So we have 2. We have 5. We have 7. We have 8. We have 10. We have 12. Then the totals will come. All right, so let's look at this, the data. So I'm trying to put the data on a table so that we can do the cumulative frequency. But you can still do cumulative frequency even without a table if you know what cumulative frequency actually means. So how many times do 5 appear? Once. So 1. How about 2? We have 1. How about 7? Once. How about 8? Come again. 8 appear 2 times. So 8, 2 times. How about 10? 3 times. How about 12? 12 appear once. So we have 1. Okay. Now, if you want to do the cumulative frequency for 2, okay. So this is what we call I'm going to show you how we do the less than cumulative frequency and then the more than cumulative frequency. So let's do the less than cumulative frequency, and then let's do the CF, more than cumulative frequency. So let's do the less than cumulative frequency and the more than cumulative frequency. Then I'll explain what it means in statistics. Now look at these two. The reason why we call this less than cumulative frequency, the normal cumulative frequency that you know, we call it less than. The reason is because, let's check these two. It simply means that the cumulative frequency, the less than, simply means that check the data sets. Okay? The values that are less than or equal to 2. So check the data set. So on the original data, the values less than or equal to 2, meaning values that are smaller than or equal to 2. And that is only 1 here. The rest are all greater than 2. And that is only 1 here. And that's the reason why the less than cumulative frequency for these two would also be 1. Here will be 1. So from the original data set, values less than or equal to 2 is what? It's 1, because 2 appears only what? 1. The rest are all greater than 2. Okay, so if you check the original data set, the cumulative frequency simply means that if it is 1, if the cumulative frequency here is 1, it simply means that if you go to the original data, if you take the value 2, the values that are less than or equal to 2 is 1. Let's check the 5. How many values are less than or equal to 5? It's 2. So let's count and see. This 2 is less than 5. The 5 itself is also less than or equal to 5. So we have 2. But if you want to confirm, check. If you want to find the cumulative frequency without even understanding this principle, let's check. How will you do the vertical approach? If you add this 1 to this, you get 2. Okay? Yes, so if the cumulative frequency is 2, what it means is that if you go to the original data, values that are less than or equal to 5. Okay, so check this 5. From this original data, how many values here are smaller or equal to 5? It's 2. Is this 2 and this 5? Okay. Now let's go to the next one. Let's take 7. How do you know the cumulative frequency for 7? It simply means that values that are less than or equal to 7. Let's count it together. Values less than or equal to, how many values do we have? We have this, and we have this. Values less than or equal to 7, they are 3. So what that means is that if you actually understand what cumulative frequency means, if we give you a raw data, you don't even need to go through all the stress to use vertical approach or diagonal approach. You can just look at the data and tell the cumulative frequencies without calculating. Is that okay? Great. So let's look at so we have 3. Let's confirm. If you want to use the vertical approach, if you do add till you get to this one, 1 plus 1 plus 1, you still get 3. And that is why we call it the less than cumulative frequency, meaning values that are less than or equal to that value. That's why we call the original cumulative frequency that you know, the normal one, or the commonly used one, we call it the less than cumulative frequency. Now, let's move on to the next. If you want to check, let's check for 8. What's the meaning of less than cumulative frequency for 8? Values that are less than or equal to 8. How many values do we have? Let's check. So we have 1, we have 2, we have 3, we have 4, we have 5. Okay, good. Let's come and confirm and see. Let's do the usual calculation to confirm and see. If you want to get the cumulative frequency for this 8, the frequency is here. Add till you get to these 2. 1 plus 1 plus 1 plus 2, you get 5. Okay, and that's why we call it the less than cumulative frequency, meaning values that are less than or equal to 8 on the original data. Okay, so let's check how many values are less than or equal to 8. So if you take the 8, how many values are less than? This is the 8. Let's count them together. Values that are less than or equal to 8. So we have 1, we have 2, we have 3, we have 4, we have 5. If you check, we have the same 5 as the cumulative frequency. And that's why the commonly used cumulative frequency, we call it the less than cumulative frequency. Let's do for the 10. Values that are less than or equal to 10. So we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8. Okay, let's confirm. If you are still doubting, you can still confirm. You add the frequencies till you get to which one? 3. So 1 plus 1, 2, 3, 4, 5, 6, 7, 8. You get the 8 over here. Now let's do the last one for the 12. Less than cumulative frequency for 12. What does it mean? Values that are less than or equal to 12. Let's count. How many values are less than or equal to 12? Of course, everything. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is 9. So you write the 9 over here. Then you remember the last cumulative frequency, the last less than cumulative frequency is equal to the total frequency. So if here is 9, of course, it means here is also 9. Now let's look at what the more than cumulative frequency means. Okay, the more than cumulative frequency, what does it mean? So if you take the more than cumulative frequency, the more than cumulative frequency means that you are doing the cumulative frequency from down, from below. So it means vertical, but from down. So down, up. But you see, the less than cumulative frequency, you are doing it from top down. So the arrow goes this way. So you add it from here down. Okay, so when you are adding, if you want cumulative, the first is equal to the first. If you want for here, you add this 1 to this, you get 2. If you want this 3, you add 1 plus 1 plus 1, you get 3. If you want this 5, 1 plus 1 plus 1 plus 2, you get 5. If you want this 8, so you see, we are adding from down, from top down, from top to down. That's the less than. Now, with the more than, you do it from down up. Okay, so this is how you are going to do it. Okay, so the first one, here the frequency is what? 1. So the first, the less than, the more than cumulative frequency here will be what? 1. But we are adding upward though. So if you want the more than cumulative frequency for this 3 is 1 plus 3. That will give you. If you want the next more than cumulative frequency for these 2 is 1 plus 3 plus 2. That will give us 6. If you want the next 1 plus 2 plus 3 plus 2 plus this, that will give us 7. If you want this one, 1 plus 3 plus 2 plus 1 plus 1, that will give us 1 plus 3 plus 2 plus 1 plus 1 plus 1, that will give us 9. And another principle is that the first more than cumulative frequency should also be equal to the total frequency. That's one way you have to be able to confirm. But now let's look at what the more than cumulative frequency means. The more than cumulative frequency means that values that are more than or equal to the value. So let's take this 5. How many values in these data sets are more than or equal to 5? How many values are more than or equal to 5? It's only the 2 that will go out. Okay? Okay, so values that are more than or equal to what? 5. So let's count it together. Let's count it. How many values are we going to have? Values that are more than or equal. So we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8. Come and check and see. You see the more than cumulative frequency is 8. Yes, sir. Okay. Now let's check for 2. Okay. So when we want to understand the more than cumulative frequency for 2, what does it mean? Values that are what? More than or equal to what? 2. Let's go and check. How many values are more than or equal to 2? Of course, everything here, they are all more than or equal to what? 2. So let's see how it will go. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. All of them. And that's why the more than cumulative frequency too, of course, is 9. That is what it means. But you see, it's very easy to know how to understand that if you want the more than cumulative frequency, we do it from below. But it's important for you to understand what it means. So if we do this on paper that, oh, okay, the more than cumulative frequency, if here is 1, here is 1. Okay, if you want to get to the next one, you add this 1 to the 3. But then you don't know what it actually means. What it means is that, so if I tell you, okay, there is a data, a value is 2. The more than cumulative frequency of that 2 is 5. What does it mean in statistics? What it means is that when we go to the original data, the values that are more than or equal to the 2 is 5. Or the values that are greater than or equal to the 2 is 5. Is that okay? Yes. But remember that the commonly used frequency is which one? The commonly used cumulative frequency is the less than cumulative frequency. All right, so now we understand the 2 main types of cumulative frequency. Let's do an example. Let's do a typical example. Let's have a data, a last example on the more than and less than cumulative frequency. So we have H in years, we have frequency, so we have the cumulative frequency, less than, cumulative frequency, more than. So we have, let's start from 3, we have 4, we have 8, we have 9, we have 10, we have 12. So, all right, so let's put in some frequencies. Let's do here 4, let's do here 5, let's do here 2, let's do here 1, let's do here 6, let's do here 3, let's do here 2. Okay, so let's do the less than cumulative frequency. Remember, the commonly used frequency. This less than cumulative frequency is the common one that you know. That is what you would come by using the vertical additions or the vertical computations. And then the less than cumulative frequency from down to up. It goes in that order. So down to up will give us the more than. Okay, so let's do for the less than cumulative frequency. Remember, the principle still holds. The principle still holds. The first frequency is equal to the first cumulative frequency less than. The first frequency is equal to the first cumulative frequency less than. So what's the first frequency here? 5. So the first cumulative frequency would also be what? 5. Okay, let's do the other principle. The last cumulative frequency less than is equal to what? Is equal to the total frequency. So let's find the total frequency. 5 plus 2 will give us 7 plus 1, 8 plus 6, 14, 15, 16, 17, 18, 19. So here is what? 19. But there is another principle too. The total frequency is also equal to the first more than frequency. Is that okay? So there are times in statistics we can intentionally omit this in a table. Then we will give you the more than frequency. Then we will give you here 18. This one will not be there. Then what it means is you use this more than frequency to get the total frequency. Then after getting the total frequency, you now have to add all these frequencies and subtract from the total to get the missing frequency. That is also another principle you should know. So let me clean this one. So here is 90. Here was what? 2. Okay, good. So if here is 19, what will be the last cumulative frequency less than 19? Good. So now let's use the vertical approach to get the cumulative frequency. If you want to know the cumulative frequency for these two, add this 5 to these two. We are doing the vertical. 5 plus 2, that will give us 7. Or you can use the vertical approach too. You add the previous cumulative frequency to the current frequency. That would also give you 7. But let's go vertical. If you want to know the cumulative frequency for the 1, 5 plus 2 plus 1, that will give us, then you write the 8 over here. If you want to know the cumulative frequency for this 6, you add the frequencies till you get to this 6. So 5 plus 2 plus 1 plus 6, that will give us, then you write the 14 over here. If you want to know the cumulative frequency for this 3, you add the frequencies till you get to the 3. So you add the frequencies till you get to the 3. That will give us. Now, if you still doubt this frequency here, you still doubt the principle, you can still continue to add the frequencies till you get to the 2 to get the 19 over here. Is that okay? But always use the principle. Now, let's look at the more than cumulative frequency. The more than cumulative frequency, the basic approach is that add the frequencies from down. So down, up. So vertical approach, but this time you are adding downwards, up. Okay? Good. So, but the last frequency is equal to the last cumulative frequency more than. So if here is 2, it means that here is also what? 2. So if here is 2, here is 2. Here is 2, here is 2. Okay. We are adding upwards. So if you want to know the cumulative frequency more than for here, add these 2 to this 3, you get what? If you want to know the cumulative frequency more than for here, add these 2 plus 3 plus 6. What are we going to get? 11. If you want to know the cumulative frequency more than for this one, 2 plus 3 plus 6 plus 1, what do you get? 12. If you want to know the cumulative frequency more than for these 2, 2 plus 3 plus 6 plus 1 plus 2, what do you get? Come again. If you want to know the cumulative frequency more than for this 5, you add the frequencies from down till you get to 5. You are going to get 19. And you see now the principle works. The first cumulative frequency more than is equal to the total frequency. And then the last cumulative frequency less than is also equal to the total frequency. So in exams, like I mentioned earlier, we can give you this in the table and you will not have anything over here. We will take this one out. We will take this one out. And you may have to calculate for the total. You have to use this principle to get the total. Then when you get the total, you add the given frequencies and subtract from the total to get the missing value over here. So pay attention to that one as well. So you can pick the principles. So one principle you can note over here is that the total frequency is equal to the last CF less than is equal to the first CF more than. Is that okay? That is also another principle that you can pay attention to. And another one that I didn't add is that the last frequency is equal to the first CF more than the last CF, sorry. The last frequency is equal to the last CF more than the last CF more than. That is also another principle that you can learn from this. Okay, let's move on to the next. Yes. Let's move on to the next. Let's look at. Good. All right. So let's leave it over here. Good. So cumulative frequency. There is a way that you can use, and the less than and more than cumulative frequency is very important because it can be used to calculate the median. There is an approach, you can use the less than. So it's not just a computation or analysis in statistics we are just doing. There are times that you can use the less than and then the more than cumulative frequency to calculate for the median. And we have a graphical presentation for that. We call that the OGIF chart or graph. Okay, so there is a way that you can use the less than and the more than cumulative frequency to calculate for the median. So let me just walk you through how that works. So for example, if we give you a table like this, let's see a cumulative frequency table like this. Let's say here is 2, here is 4, here is 5, here is 6, here is total, here is frequency, here is cumulative frequency, here is cumulative frequency. So here is the less than, here is cumulative frequency, here is the more than cumulative frequency. So let's do here 1, let's do here 3, let's do here 2, let's do here 4. So the total we will get this will be 7, this will be 10. We have 10 over here. Let's do the less than cumulative frequency. So the less than cumulative frequency, here will be 1, here will be 10, here will be 4, here will be 6, and then here will be 10. That's over here. The first one here will be 4, here will be 6, here will be 6, here will be 9, here will be 10. Okay, yes, so that's so we've done the more than cumulative frequency. You know, if you want to calculate the median, we have something we call the OGIF graph, where you can plot the cumulative frequencies, the less than and the more than cumulative frequencies, to help you to get the median. So you can do a graph like this. Here will be 0. And usually, so you can have a look over here. So you see we